Hi all, and welcome to this video. Today we'll show you the zkVerify attestation mechanism in action, currently targeting 3 testnets: Sepolia, Jenkins, and Go. Alright, let's get started. First of all, let's just have a brief introduction on what the attestation mechanism is. As you can see from the official docs, it is one of the components of the zkVerify architecture, and it allows to publish an attestation, or a commitment in other words, that a given set of proofs have been submitted and verified on the zkVerify main chain. The attestation can be published on any network, given the assumption that the corresponding zkVerify smart contract has been there deployed. This gives the zkVerify project a great flexibility, helping users to find the perfect balance between security and costs when settling their proofs. Time to have a closer look now. So here I am on the Polkascan Explorer. We have all the typical features of such a tool with blocks, extrinsics, that's an alias for transactions in the substrate slang, events, etc. Let me just find a proof, for example, a zk-sync proof, this one. This is a proof someone has recently posted on the zkVerify main chain. It was not me, but don't care. The aspect to note here is that this proof submission is the only interaction a user has to have with the zkVerify network in order to achieve the full attestation. So we can inspect the transaction body and in particular focus on its events, like this new element event, and in particular this value 6156, that is saying this proof will be included in the attestation tree with ID 6156. Now let's look for the block containing the main chain attestation. So here we were at block 579 with the submission of the proof. So let me search for the associated attestation event. That is this one in a few later blocks, 8 blocks later. This event is again with the ID 6156 and with this Merkle tree root. So this is an event automatically generated by the zkVerify main chain itself, and it is later relayed to the other networks by the attestation mechanism. Just take note of the values for attestation ID and Merkle root. We'll check them in a moment. Moving on, let's jump on the Sepolia Explorer. We can get this link with the address of the zkVerify contract. So we are on the Sepolia network, Etherscan, and on the zkVerify contract. So from the list of transactions, pick this one, the last one, and let's navigate to the logs tab, and we get these 2 values. This one that is the Merkle root of the tree, as we saw before, okay, and this one that is the hexadecimal representation of our ID 6156. Okay, and in a totally analogous way, we can check the other 2 networks. So the Jenkins one, again, let's navigate to the contract, then logs, and again we can see the attestation ID and the Merkle root. Finally, for the Gobi one, we can confirm that we have the same values. So let's go on the last transaction, logs, and again we can see the attestation ID and the Merkle root. So that's it. Just to summarize what we saw, we got a proof that is submitted and verified on the zkVerify main chain. We got the proof is attested on the zkVerify main chain as internal event. And finally, we got the attestation mechanism relaying the main chain event to the zkVerify contracts deployed on the other network: Sepolia, Jenkins, and Go. Wanna try this? It's up to you. Submit your proof on the zkVerify and just wait on the other side. Bye bye!